Hello everyone, welcome to my network lab. In this lab, we are going to see what is Q&Q and how it is configured using Arista switches. 802.1q is an IEEE standard created in 1999, often called as .1q. Q&Q means double times 802.1q, expanding the VLAN space to 4094 times 4094. 802.1q is a 4 bytes or 32 bits tag that can be added in an untagged Ethernet frame that contains the VLAN information. An untagged Ethernet frame is the one without 802.1q tag. A VLAN tagged Ethernet frame is the one which contains the 802.1q tag. And when there are two 802.1q tags, it is called Q&Q tagged frame. The outer 802.1q tag contains the outer VLAN ID and the inner 802.1q tag contains the inner VLAN ID. In this scenario, we have our data center and we provide IT services to our customers. We have two customers, customer A and customer B. Let's assume that our customers' offices are situated in one end of the country and our data center is situated in the other end. It is our responsibility to manage their network and to make sure that they can access their servers seamlessly. In order to extend the layer 2 traffic from our customer sites to our data center, we will ask a big provider called provider X to extend it for us. This is when the provider X uses Q&Q technology. Provider X will dedicate a VLAN ID for us to encapsulate all our customers' tags using an outer VLAN tag. In this case, provider X dedicates VLAN 100 for us to create the Q&Q tunnel in order to extend the layer 2 traffic for us. Let us start configuring our customer site first. Let's take customer A. Customer A is using VLAN 100 and this is their subnet. So let's go to their switch. Customer A's edge switch. So logging in, enabling config host name, let's say customer A edge switch. So in Ethernet 1 it's switchport access VLAN 100. Interface H1 switchport access VLAN 100. So in Ethernet 2, which is facing the provider, it is switchport trunk. So basically that is the complete configuration that we'll be doing in the switch. So now let's go to customer B. Host name, customer B edge switch, interface ETH1, switchport access VLAN 200, interface ETH2, switchport mode trunk. So that is all the configuration in the customer switches. Now let's configure our edge switch that is located at our data center. admin host name configure host name. Let's say our edge switch at our data center. Okay, so the port that is facing the provider switch is always switch port mode trunk. Interface ETH2 switch port mode trunk, and then interface ETH4. This is facing the customer A server, so it's VLAN 100. Switch port access VLAN 100, and for VLAN interface ETH5 it's VLAN 200. Okay, writing memory. So basically that's all the configuration that we will be doing in our switch at the data center. Now let us configure the provider area. The .1Q tunnel always starts and stops at the edges of the provider switch, which means the encapsulation and the decapsulation takes place in these ports and this port. So the switches that are in the middle will always be switch port mode trunk, which will allow all the traffic to the other switches. In this case there is only one middle switch, but in real life scenario there can be hundreds of middle provider switches. Let's configure the ports that are facing in the middle. So going to the provider middle switch, admin option, admin enable conf host name, let's call it P middle switches, interface ETH2 switch port mode trunk. Similarly interface ETH1 is also switch port mode trunk. So this is the config that we will be doing in the middle switch. And in the provider edge switch that is in our customer side, this is the one, admin enable config interface ETH2, which is facing the middle switch, is switch port mode trunk. Similarly the provider edge switch that is facing our data center edge switch is here. Let's configure admin enable conf interface ETH2 switch port mode. That is facing the middle switch. It should be interface ETH1 switch port mode trunk. So the middle switch is good, it's configured on both the sides. So now let's configure the ports that are facing the customer edge switches. So interface ETH3 switch port access, and our provider is going to use VLAN 100 as Q&Q VLAN. So switch port access VLAN 100, switch port mode dot 1Q tunnel, and similarly in ETH1 is ETH1 switch port access VLAN 100. No matter how many customers we have, but our provider is just going to give us a single VLAN to encapsulate all our customers VLAN and to decapsulate it at the end. So it's still VLAN 100 and switch port mode dot 1Q tunnel, write memory. So basically that is all the configuration we will be doing in the switch. So the provider switch that is facing our data center and the port that is facing our edge switch interface ETH2. Similarly, it's VLAN 100, that is the Q&Q VLAN provided for us by our provider. Switch port access VLAN 100 switch port mode dot 1Q tunnel. So that is all the config which we have to do in the switch. Let's configure the IPs for the users and the servers. So customer A user, I will give him the IP in the subnet 10.10.10. let's say 1/24, and I will give the server's IP as the gateway 10. So the IP is configured, and let's configure the IP for this user. IP is also using the same subnet and the same IP 24, and the gateway is also the server, same server, but they are in different VLANs. Okay, and I'm configuring the server. So IP 10.10.10.10/24, and the gateway will be the user for the slab. Okay, and similarly for the server B, let me configure the IP subnet mask and the user B's IP. Okay, so the IPs are configured. So I'm just going to try to ping from server B to customer B's user. Customer B's user is IP is 10.10.10.1, and we will see the packets using Wireshark. I'm going to capture the packets that will go in Ethernet 1 of this provider switch. The packets will start to capture. Let me start the ping. Starting the ping. So if you see, there is a request. There are two 802.1q tunnels tags. Both are, so this is the outer VLAN tag and this is the inner VLAN tag. Since it's going from customer B, in the drawing you can see that B will be having outer VLAN tag 100 and inner VLAN tag 200. But it is unreachable. Why? Because we didn't configure the VLAN ID in the middle switch. So the VLAN which was used by the provider is only the VLAN 100. So let's configure that and do the ping test again. Just gonna add the VLAN 100 and let's see if we can reach the user. Yeah, and now we can reach and see the packets. It's passing. So if you see the packets, the outer tag is 100 and the inner tag is 200. So let's stop the ping. Okay, it's stopped. So I'm closing the packet tracer and gonna do the same from user A to see if we can reach their server. I think I already have a session of user A. Here it is. So user A is going to reach his server. Ping 10.10.10.10 and he can reach it. So I'm going to run continuous pings to see how the packets are captured from different switches. So let's see how it is going to be captured in Ethernet 2. Open. So I'm receiving the packets. So if you see, the outer VLAN ID is 100 and also the inner VLAN ID is 100. So that is what I have mentioned in the drawing. The customer A's outer VLAN is 100 as well as the inner is 100. So the ping is still going. Let's see how it's gonna be in the middle switch. It's Ethernet 1. Let's go and see there. Capture. In the middle you still see both the VLAN IDs 100 and 100. And let's see how it looks in our side. Sharing packets in Ethernet 2. So there are some packets that is coming from user A and going to their server. So there is only one VLAN tag because the provider's VLAN is decapsulated here and the original customer A's VLAN tag is only shown here. Since they are both 100, it's not clear, so I will just ask the customer B to ping their server. So I will go to the customer B. Before that, let me stop customer A's ping to make sure it's not bothering us. Okay, so I stopped the customer A's ping. So I'm asking customer B to ping his server. So let's see the packets now. So these are the new packets, and for example, if I open this, you will see the ID as 200. This is the original VLAN ID from the customer, and it's been going back here to their server. The provider's VLAN ID 100 has been decapsulated at this point. But if you see here, let's take Ethernet 1 of the provider edge switch. You will see both the VLAN tags, outer and inner. The outer tag is 100 and the inner tag is 200. So basically that is all about Q&Q. It's a simple yet powerful technology. I will give the config for all the switches in this video's description. Thank you so much for watching.